So first of all, I'm just going to ask, let's see. Matt, I'm going to ask you, what did your picture in number 1 look like? I should have gotten whiteboards out for you guys to draw them, but I didn't.
We just had a red wire connect positive.
Okay.
And then we had it connect a metal piece on the bulb.
Okay.
And then we had from the negative, the black wire connect a metal piece to the bulb.
Okay, so here's my battery. And there's my light bulb, something like this-ish. Maybe yours had a little base on it because you had the little metal pieces. And then you had a red wire connecting to one side, and you had a black wire connecting to the other side, something like this.
Yeah.
Is that right? Okay. How many other people had a picture that looked something like this? Yeah? Awesome. That's good, because that's how you make it work, right? So you're establishing a circuit. All that a circuit is a loop. It's a loop that electrons can flow through, okay? And we'll get into how they flow soon, but that's all that a circuit is. Now, when you have a loop like this, one of the common questions is, do I have to have a red wire one place and a black wire another place? And the answer is no. No. Red wires and black wires are exactly the same on the inside. Okay? Just like people. Aww. Right? They're all the same on the inside. It's just that this one's got red coating on it, this one's got black coating on it. That's it. The only reason that they make them in all different colors is so that when you're building a circuit, you can keep track of where one wire goes and where another wire goes. That's it. So one note that you might want to write down in your notes, let's go ahead and make a little notes sheet here, okay, is that when you're building a circuit, the color of the wire does not matter. They're all the same. Okay. The next little thing that I want to share with you is that in physics classes everywhere, students study circuits, and when they do, we always start drawing them this way. But I will tell you that if you walk into a college level physics class and you start drawing circuits this way, people are going to look at you and be like, they're going to giggle. So I'm going to give you kind of an inside scoop as to how to draw a circuit so people don't giggle at you, okay? Because this is very accurate, and for an artist, this tells you what's going on. But for an engineer, for a physicist, for someone who's looking at a circuit diagram, an electrician, that means nothing. So we're going to learn about circuit components. One of the circuit components is what, Leanne? What's one of the things that you had in your circuit? A battery. And we usually draw a battery like a rectangle and a little bump, right? And this is the positive part of the battery. And this is the negative part of the battery, just FYI in case you didn't know, okay? And we'll talk about how the battery does what it does later, but that's what I want you to know. This is how we draw the picture of it. But when we're going to draw the actual circuit component, instead of drawing it like that, we draw it with a short line and a long line with wires coming out. Okay? This is the circuit diagram version of a battery. The long line represents the positive side. The short line represents the negative side. And then those lines coming out are wires. Okay? If you have more than one battery stacked together, you know, like in the flashlights, the classic flashlight that you think about, where you put two batteries in. If I'm doing that, then instead of just having one cell, is what they call it, then I would have two stacked together. And so I put them like this. Oop, come on, stylus. Now, perhaps counter to your wishes of excitement, even if I have 7 batteries stacked together, I still draw it like this. Okay? This just represents multiple batteries, whereas this is just one cell. Okay? For our purposes, either one is fine all the time. I don't care. And I'm not going to get bent out of shape one way or another. But I want to tell you that you might see both of those, so I just want you to know what they are. Okay, that's one of the circuit components. Let's see, Miss Emma, what's another thing that you had in your circuit? Wires, for sure. And if you remember in the picture that we drew, we had wires and they looked like they were just kind of going like this, right? I'm just going to kind of draw them through there. That's what our wires look like. That's what they look like. That's what they physically look like. Here's the funny thing. is that in a circuit diagram, instead of having them all curvy and pretty, I mean, I think it's pretty that way. Instead of doing that, the way that we draw wires is that they are all either exactly vertical or exactly horizontal. And when they turn at a right angle. That feels a little bit funny, but it's just the way that they're always drawn. So I'm going to go ahead and draw my wires here. And they're going to bend down like this. Okay. So the thing that you need to know about wires is that they bend at right angles, which is kind of strange. And I'm not saying that you need to bend your actual physical wires that way, but that's how you draw it in a circuit diagram. Okay. What's our third piece that we added? The third thing we had. What was it? Light bulb, right? And so when we draw that, so I'm just going to kind of make my little cute little circuit here. This is my real life circuit. Then I've got my light bulb, and I might draw it something like this. What's that this thing in the middle? Do you guys know what that is? What it's called? It is the filament. It's a little tiny wire that's usually made of metal called tungsten. And tungsten is a metal that when it has a lot of current going through it, it glows. So they figured, hey, that's a good one, then we'll use it. So that's what it is. Okay, so that's how we usually draw a light bulb or something like that. Maybe you have the base on it, like we were talking about before. So maybe it goes like this, right? And you got the base on it, or maybe you clipped it on the underside and whatever. But that's not how we're going to draw a light bulb for our purposes today. Instead, a light bulb is going to be drawn just like this. So it's a circle with a little loop in the middle. That's all it is. I'm going to go ahead and connect my wire here. So this right here is the circuit diagram version of the circuit you drew in number 1. Okay? You absolutely do not need to go back and fix it. That would be silly. That would be a waste of our time. But moving forward, when you draw a circuit, you're going to draw it using our circuit diagram pieces. Okay? Is that making sense? Yeah.
Wouldn't it be like the top one since there's only one battery?
Yes. Yeah. And like I said, I'm not going to get bent out of shape one way or another if it's the one battery or 2. Yeah, it's not. For our purposes, it doesn't really matter. We good so far? Okay. So now that was the first piece. Then we looked at steps 2 and 3. So you did the same with 2 bulbs. Now, it was really interesting going around. And the reason I do this is because I don't want to tell you how to do things. I want you to investigate and see and look at it. So I want you to look at your pictures. And there were some of you that you made 2 circuits and they look different. And I came over and said they're the same circuit, right? And there were some of you that had the same circuit, one type of circuit, and other people that had the same circuit, a different kind of circuit. We're going to look at both of those kinds of circuits here, one at a time. The first one I'm going to talk about is the one that makes just a loop. So I want you right now to look at your numbers 2 and 3 and figure out which one makes just one loop. Identify it, put your finger on it, check with your partner, make sure they agree. Which one makes just one loop? Find it? Okay. Now, really quickly, talk to your table mate. Is that the one that was bright or dim when you compare the 2? It's the dimmer one, is that right? Yeah. So I'm going to draw that. I'm going to go ahead and draw it on my notes because I'd like you to draw it on your notes as well. Okay. This kind of circuit that makes just one loop with multiple, let me try that again. Light bulbs. Okay. Does anybody know what that kind of circuit is called? You've got just one loop. It's okay if you don't. I'm just curious. It starts with an S. It's called a series circuit. Okay. So new knowledge for us. It's great. And that's not something that I would necessarily expect you to know unless you've done this or seen this before. So in a series circuit, on your paper, I'm actually going to have you do this first. I want you to translate what you had drawn on your sheet into a circuit diagram on your notes. Can you do that? So the one that's a loop, draw that as a circuit diagram on your notes. Go ahead and do that. Check with your neighbor, see if they agree. Let's see how we do. All right. Have you got a picture? Yeah? So you've got a battery, or maybe you've got two. I'm just going to go ahead and draw it with one. And then you've got a light bulb. Whoa, that light bulb looks goofy. Let me try that again. And then you've got a light bulb, something like that. Now here's the thing. The location of the light bulb on the circuit does not matter. So you could have put the two light bulbs right next to each other with a bunch of wire in the front and the back. You could have put one right next to the beginning of the light or the battery and one right next to the end. Again, it does not matter. As long as you have two light bulbs that make one loop, you're good to go. Okay? We're going to make a note here that the series circuit was the one that was very dim. And how did the lights, the brightness of each bulb compare? Were they the same brightness or were they different brightnesses? Did you take a note of that? Yeah. Leanne, did you notice or no?
Like, just one circuit.
Like in this circuit, this bulb and this bulb, were they the same brightness?
You said so.
Same? Do you guys agree? They should be the same. Dim, but both bulbs have the same brightness. And we'll talk about why that is in a couple of days. We're not going to do that right now. I just want you to have that written down. So that's one of yours. It's either number 2 or number 3, depending on which one you did first. The other one, how many loops does the other circuit have in it? Has 2 loops, right? So there are 2 loops, 1 bulb on each loop. So the second one, there are 2 loops with 1 bulb on each loop. Does anybody know what this one's called?
Double series.
Good guess. It's not, though. It starts with a P. It's called parallel. Go ahead and try and draw a parallel circuit using your circuit diagram skills on your notes. This one might be a little more tricky to draw. If you need to talk to your neighbor, compare a little bit, that's absolutely fine. Physics is much more pleasant being done with others, right? Working together, we learn. It's a beautiful thing. Once you've drawn your picture, if you need to double check, you can make sure that there are 2 loops by tracing with your pencil to see if you can get 2 loops where each 1 bulb is on each loop. Going from the battery back to the battery. Can you get there on one of 2 different loops? Check with your neighbor. Make sure that theirs looks great. How'd we do? We good? So we have a battery, or maybe 2. Excuse my light bulb's lack of circliness. So here's one light bulb on one loop, right? There are lots of ways to draw the second loop, okay? I'm going to show you the most traditional, okay? But it doesn't have to be this, but this is the way you'll see it the most. The way you'll see it the most is for it to come off like that, okay? It's okay if you have it going the other way, like if you have it going onto the left side. So you've got one on this side and one on this side. That's okay. We just don't usually draw it that way, okay? Generally, we draw it this way. So even if you didn't draw it this way before, go ahead and draw this one also so that you've got this for reference when you're working on some homework later, okay? In this case, were the bulbs as dim as they were in the series circuit? No, they're brighter. This part's really important. How did the brightness of the two bulbs compare? Did you notice? How do they compare? I think you're looking at it right now.
They look the same.
They look the same. And in fact, they are the same. Okay? The bulbs have the same brightness. Okay? Just as I said with the series circuit, how you could space them out in any way you wanted, the fact that this second loop, this bigger loop, has more wire does not mean that this light bulb is going to be dimmer. Okay? That's a very common misconception. But again, what I'm saying is that just because this one has more wire does not mean that it will be dimmer. The bulbs will be of equal brightness, okay? And we'll talk about why that's true later, but I just want you to know that for right now that they are the same brightness. Okay? How are we doing? We okay? Okay. Now I'd like you to flip your green sheet over. On the back, your task is to start with 3 bulbs, and you're going to number them 1, 2, and 3 in your diagram. My task for you is to design at least 3 fundamentally different circuits. Okay? So if you're not sure, then let me come over and I'll take a peek. Okay? You can draw pictures of them. I would encourage you to connect the 2 batteries. And by that, I mean, like in your actual physical space, you got one and then you've got another. It says to tape them together. That was from an old lab. I would just encourage you to connect the positive of one with the negative of another and then have those go out to the rest of your circuit. Okay? I'm going to give you about, 5 or 7 minutes or something like that to work on this.